Hello, grade 8. Welcome back, and let us continue then with part 2 of this lesson, solving equations using exponential laws. Please bear with me today. I'm recording in the city, so you're going to hear some taxis hooting and. But maths doesn't stop, right? We will continue learning, yes. So now let's look at example 1. And if we're solving for x, let's say we're using a table so that you can understand better what's going on. All right, and when we say we are going to look at the input, it means that in the place of x, all right, whatever input we have, whether it's 1, whether it's 2, 3, 4, or 5, we're going to plug it in the place of x, and then we are going to solve. All right, so now in this case we have x squared is equal to 9. Now what would be the value of x in this case? All right, let's see. If we plugged in 1, what would we get? So in the place of x we now put 1. Now we know 1 to the power of anything will be equal to 1. Okay, so that's basically our output. What if we put 2 in the place of x and we squared it? Okay, 2 to the power 2 just means that we are saying 2 times 2, and that would give us an output of 4. Do we have 9 yet? No, not yet. So now let's look at 3. If you had 3 squared, and I see some of you are like, yeah, hey, yes, it has to be 3. Okay, I can't really see you. I'm imagining in my mind. So if we have 3 squared, 3 times 3, that will give us 9. All right. So there we go. If we have an input of 3 and we square that input, our output will be 9. All right. So we know then that x is actually 3. All right. But let's just complete the table. So if we say 4 squared, that would be 16. And if we have 5 squared, that would be 25. All right. So that is how you would solve an equation using an exponential law, especially with the table. All right, so you're trying to figure out using whole numbers or even integers at times, because if you were to put negative 3 squared, that would also give you 9. Okay, because it's the same as negative 3 times negative 3, and we had already spoken that negative times negative gives you a positive, and then the 3 times the 3 will give you 9. So x can either be plus or minus 3. Both of them will give you the output of 9. Now let's go to x to the power 4 is equal to 16. And again, we're going to try different inputs so that we can see what actually gives us the output of 16. So if I plug in 1 in the place of x and I make it to the power 4, anything, if you take 1 as your base and you have an exponent, any number, as long as 1 is the base, your answer will always be 1. So we know that 1 to the power 4 is 1. What about 2 to the power 4? Okay, this is literally just saying 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. Okay, so 2 to the power 4 is 16. So we already have our answer there, that x is actually equal to 2. What about negative 2? Let's try it out. I know I don't have it as my input, but I think you should always be wondering, what if you had a negative? Would that also work out? Yes, it would, because negative times negative is positive. Positive times negative is negative. Negative times another negative will give you a positive. And then 2 times 2 times 2 times 2 is 16. So our answer for x can either be plus or minus 2. Okay, but let's continue. What if you had 3 to the power 4? Well, you'd say 3 times 3, which is 9, times 3, which is 27, times 3, which is actually going to be 81. What about 4? Okay, so if you have 4 times 4, that will give you 16. What about 16 times 4? Well, we have our calculator, we can actually use it. So yeah, so if we have 4 times 4, that's 16. 16 times 4, that's 64. 64 times 4, that's 256. That's 4 to the power 4, right? What about 5 to the power 4? Same thing. So we can actually just say 5 to the power 4. Okay, and that's 625. But we were looking for the x value that would give us 16. Now, x to the power 3 is 125. So how are we going to solve for x using this table? Well, if we have 1 to the power 3, that will always give us 1, right? Brackets are there for safety. Yeah, it's like putting on your safety belt in the car. That's what brackets are like, to keep you safe. Okay, and then if we have 2 to the power 3, that's basically 2 times 2 times 2, which will be 8. Okay, so we're not there yet at 125. How about 3 to the power 3? So 3 times 3 is 9, times another 3, it's 27. How about 4? We just calculated it, right? 4 times 4 is 16, times 4 is 64. What about 5? So 5 times 5 is 25, and what is 25 times 5? It's actually 125. So there we can see that x is actually equal to 5. How about negative 5? Let's see. So if I have negative 5 times negative 5 times negative 5, so it will be negative times negative will be a negative. 5 times 5 times 5 is 125. So you cannot have x being equal to minus 5. It only works for x is equal to 5. Alright, now let's get to example number 2. Now it says, find the values of the unknown in each of the following equations. Alright, so we can use the table for it, or we can literally calculate it. Okay, let me show you with the previous example how you would calculate it. So let's say you have x cubed is equal to 125. I can, to get rid of the x cubed, I can use a cubed root. Alright, so x cubed can be removed by a cubed root, but what I do on the left I must also do on the right. Okay, so now I'll be left with x this side because the cubed root and the x cubed, or the cubed part of it, will cancel, so I'm left with x. And then inside here I know I have 5 times 5 times 5. So basically the cubed root of 125 would simply be 5. So that's the same principle we're going to use in example 2. We are going to fill in the table to find the answer, but we're also going to solve a little bit on our side. Okay, so what if we had an input of 1? Okay, so you would have 2 and then 1 to the power 3 times 1 to the power 3, and that's basically going to be 2 times 1, which is just 2. And then we still have our 2 there, our brackets, our safety belt. We're going to put 2 there in the place of n, and we are cubing it. Okay, so 2 times 2, that is cubed, is actually 8. And what is 2 times 8? That is 16. So there we go. What about 3? So 3 cubed, we've already worked that out. That's actually 27, right? And what is 2 times 27? Well, let's check on the calculator. It's actually 54. So now we know what the value of n is. Okay, the value of, look at me. The value of n is 3. Okay, so we can say therefore n is equal to 3, because there we get 54. Let's just complete the table. If we had 2 times 4 to the power 3, that's basically 2 times 64. Okay, 128. I'm thinking. Okay, yes, 128. Or you could just put it as it is. 2 times 4 to the power 3. Okay, 128. And then what if we had 5? 2 times 5 to the power 3. So we have 250. Alright, so I've shown you how to use the table. What if we didn't have time to inspect what the answer would be? What would you do? First of all, I have 2 times n cubed is equal to 54. I want to solve for n. what am I going to do? I'm going to divide by 2 both sides. Because 2 is multiplied by n cubed, the inverse of multiplication is division. All right, so I'm going to divide by 2 on both sides. The 2's cancel here, so I'm left with n cubed. And 54 divided by 2, what would that be? You can check on your calculator, but it should be 27. Okay, there we go, it's 27. So, how do I get rid of the cube? N cube. I'm going to put there a cubed root. That's how we get rid of the cube. Put a cubed root, and we put it on both sides. All right. If I were to simplify it, this would be like n times n times n, and that would be 3 times 3 times 3. And there we have our cubed root there. So if I simplified, n would be equal to 3. What about negative 3? Would that work? Well, in this case, when it comes to cubes, not so well, hey? Because you'd have a negative 3 times negative 3, which gives you positive 9. And then a negative 3, which gives you negative 27. So the cubed root of negative 27 gives you negative 3. All right, so that doesn't really work well. So the negative in this case wouldn't give you 54, it would give you negative 54. Okay, so therefore n is only 3 and not negative 3. Now b, we have 3p squared is equal to 48. I don't know which one is quicker for you, the table or just solving it, but let's do both. So if I put 1 over there in the place of p, that's simply 3 times 1, which is 3. All right. If I put 2 in the place of p, I have 3 times 4, which is 12. All right. If I put 3 in the place of p, look at me saying cubed. It should be squared. I have 3 times 3 squared is 9. So 3 times 9 is 27. Okay. Now, if I have 3 times 4 squared, it'll be 3 times 16. What is 3 times 16? Remember, 4 squared is 16. So 3 times 16 is 48. Okay, so there we have 48. If we have p as 4, okay, so therefore p is equal to 4. What about negative 4? Once you get your positive answer, just also ask yourself, what would happen if you had a negative? Okay, so if I have 3 times negative 4 squared, that would still give me 48, because negative 4 times negative 4 is positive 16. Okay, you could always check on the calculator. Please do check, please do verify, because you want to make sure that you get the answer. So there you go. So it works. All right, so you'll still get 48. So I would say p is actually equal to plus or minus 4. Okay, out of interest, let's just finish off the table, even though we have our answer. So basically we have 3 times 5 squared is actually 25. So what is 3 times 25? It's going to be 75. So there we go, 75. I hope you're getting confident as you're solving this, because that is where a lot of people actually struggle, solving for x or n or p, whatever variable. But I hope when you're looking at this, you can actually solve these sums much better. Now let's do it the other way. So I have 3p squared is equal to 48. What I'm going to do, I have 3 times p squared is equal to 48. I want p alone, so I'm getting rid of the coefficient of p squared first. So if I multiply it by 3, I'm going to divide by 3 to get rid of it. What I do on the left, I have to do on the right. So now I'm left with p squared. What is 48 divided by 3? I hope you remember, it should be 16, but let's check. 48 divided by 3 is 16. Okay, Now, how do I get rid of the square? Okay, if I have a square there, like p squared, a way of getting rid of it so that I have p alone is to put a square root. And what I do on the left, I have to do on the right. Okay, so remember, p squared is like saying p times p. 16, I hope you remember, is actually 4 times 4. So now if I simplify it, I'll basically have p is equal to 4. Alright, but as we have shown before, if you get the positive, also consider the negative. See if that would work out. And because we already tested it, we know that actually our answer can be positive or negative. Okay, so firstly, I was literally just showing you how to use the table, and I introduced how to actually solve it, né? But now let's look at it as a whole subject. Solving equations using inverses of exponents and roots. Alright, so here it is formally written so that it is actually sinking in. Alright, I introduced it to you, I showed it to you, now let it sink in deeper. So, to get rid of the exponent, we use its inverse. Remember, just like we did when we multiplied or we added. If you multiplied, the inverse would be division. If you divided, the inverse would be multiplication. If you added, the inverse would be subtracting. If you subtracted, the inverse would be adding. So, to get rid of the exponent, we use its inverse. To get rid of the square, the inverse would be a square root. I feel like I need to use a different colored pen for that. Now, to get rid of a cube, the inverse would be a cubed root. All right, here it is. It's written down. Easier to understand, right? So now it makes sense what I was doing. Now, let us look at examples. By the way, if ever you got maybe a variable to the power of 4, a way of getting rid of it, you would use root 4. Okay, x to the power of 5, you would use root 5, and so forth and so on. That's how it works basically. Now we are not using any table, ladies and gents. We're just going to go straight to using what we've learned. Okay, and I hope you see these are the examples that we did previously. Now you're the one who's going to be telling me what to do. Firstly, we have 2 multiplied by n cubed. The inverse of multiplying is dividing. So we have n cubed is equal to 27. And then, in order to get rid of the cube, we're going to use a cubed root. So n, and you can even use a calculator here. So you're going to say shift, and there we have the cubed root. Alright, you can see it over there. I don't know if it's obvious, but yeah. So cube root of 27, not 24, that is simply 3. Okay, so there we have n is equal to 3. And even here, 3p squared, so we have 3 times p squared, so we're going to get rid of the 3 by dividing it. So now you have p squared is equal to 16, like we did previously. Now we have p squared, we're going to get rid of it with the root, square root. So now you have p is equal to plus minus 4. Okay, I'll put a 4 there because when you guys put it in the calculator, you're going to have 4. But remember what I said, once you have a number, also try to see would the negative also work, and in this case it will. So just don't forget about that negative. Alright, now example 2. It says solve for n in the following equations. We have cubed root of n is equal to 6. My goodness, what are we going to do here? So, I have a cubed root. What is the inverse of the cubed root? It is for us to cube it. And whatever we do on the left, we must do on the right. So, I am going to cube this cubed root. Okay? I'm going to cube it. And also on the right hand side, I will cube it. So the cubed root and the cube cancel each other out. We're left with n. And what is 6 cubed? 6 times 6 times 6 is 216. Or we could have just said 6 cubed. There we go. 216. Okay, that is the value of n. Now we have a square root n is equal to 5. Okay, what is the inverse of a square root? It is actually squaring. So now what I'm going to do, I'm going to square what I do on the left, I have to do on the right. Okay, put on a seatbelt. Okay, so the cubed root, no, in this case the square root and the square cancel each other out, and then we're left with n, and then 5 squared is simply 25. Okay, so that is that. And then for C, we have a root, all right, to the 5th. Okay, so we've had a square root, we had a cubed root, now we have root to the 5th. All right, so what we're going to do, we want to get rid of that root there, so we're going to bring it up to the power 5. What we do on the left, we do on the right. We also take it to the power 5. And then that will simply be left with n. Now what is 4 to the power 5? I definitely do not know that, so I will be there with you. Oh, it's 1024. Okay, so there we go, 1024. I hope you're enjoying this lesson as much as I am. And yeah, so now let's do this exercise. So here, we're just focusing on the tables, and then later on we're going to do an exercise where we're not using tables anymore, but we're actually going to look at the inverses, and then we'll call it a day. All right, so let's get straight into it. We're going to run through it. All right, so it says complete the following tables and solve for the variable. All right, so let's just complete it first, and then later on we'll solve. So now, if I have 2 in the place of x, that's 2 cubed. We know that is 8. What is 3 cubed? That's basically 27. What is 4 cubed? That is 4 times 4, 16. 16 times 4, that's 64. And then 5 cubed, what do we have there? I think that's 125. What is 6 cubed? I think we just did it. No, yes, we did. It's 216. Okay, now let's go and solve for x. So what then gives me 64? There we go. We have it there. It's x is equal to 4. Okay, so basically x is equal to 4. And now we're wondering, would a negative work? We have a cubed, right? So negative times negative is positive, times another negative, it's negative. So only 4 works, not negative 4. Now we have 4m cubed is equal to 108. So let's just then substitute 2 in the place of m. So we have 4 times 2 cubed. What's 2 cubed? 2 cubed is 8. 8 times 4 is 24. Okay, so here let's just use the calculator for simplicity. Yes. So we have 2 there, and we are cubing it. Oh my goodness, 2 cubed is 8. 8 times 4, oh my gosh, 8 times 4, not 8 times 3. I made an error there. I'm thinking 8 times 3. 8 times 3 is definitely 24, but 8 times 4 will give you 32. All right, so yes, thank goodness for calculators. Now 3 cubed is 27. What is 27 times 4? That is 108. Okay, we can see we already have our answer, but let's continue to fill in the table. 4 cubed is 64. 64 times 4, that's 256. 5 cubed is 125. 125 times 4 is 500. And then 6 cubed is 216. 216 times 4 is 864. So where does our answer lie? It lies over here. Okay? So what is m? M is equal to 3. The negative will not work, especially because we have a cubed there. Now let's go to C. We have p squared is equal to 49. All right? So if we substitute 1 in the place of p, we're going to get 1 squared. 3 in the place of p, 3 squared is 9. 5 squared is 25. 7 squared is 49. 9 squared is 81. So where does our answer lie? It lies over here. So basically P is equal to 7. What if we had a negative 7? Negative 7 times negative 7. The negative and negative are positive. 7 times 7 is 49. So positive and negative definitely work there. Yes. And then now, the last table that we're going to do is 10 times y cubed is 80. Okay, so what happens if we now put 2 in the place of y and we cube it? So 2 cubed is 8, and 8 times 10 is 80. But like I said, you know what, from the get-go, just use your calculator so that you do not make stupid mistakes like I previously did in the previous sum, right? So there we go. So that's 80. Now, what if I put there, instead of 2, I put 3? So I have 270 because 3 cubed is 27. 27 times 10 is 270. Then 4 cubed, okay, I'm going to have to rush over here. So we have 640 if we put 4, no? 5 cubed is 125. So we now times 10 is 1,250. What about 6? So 6 cubed, we know that is 216. And what's 216 times 10? 2,160. So where does our answer lie? Where's 80? It's right here, right at the beginning. Okay, so what is y equal to? In this case, y is equal to 2. Are we going to look at negative 2? No, because we have an uneven number here in the exponent, so that will not work out in our favor. So we only have positive 2. And then now use inverses of roots and exponents to solve for k. Now we have k cubed, right, is equal to 27. How do I get rid of the cube? I'm going to put a cubed root. What I do on the left, I do on the right. So now we have k is equal to 3, right? If you're not sure, go to your calculator and shift cubed root there, put 27. And then we have 3. Okay, so that's what k is equal to. Can it be negative? No, not really. We have an odd exponent over there, so that will not work nicely. Now over here, what do we do? So we have 2 times k cubed. K has a cubed root actually. So we have multiplication. In order to get rid of the multiplication, we divide on both sides. So now I'm going to be left with k, that is cubed root. And then 16 divided by 2 is 8. Now how am I going to get rid of this cubed root? I am going to cube it. Alright? What I do on the left, I also do on the right. So now I'm left with k. Now what is 8 to the power 3? I actually don't know. Let's see. It's 512. Okay. There we go. And see, we still have quite a few. Goodness, this lesson has turned out to be longer than expected. So we're gonna divide by 13 both sides because we have multiplied by 13 there. So the tablet is gonna die now. Let me do it quickly. What is 52 divided by 13? Well, it's basically 4. Okay, and then we're gonna square root both sides. So now I have k is basically going to be 2. And then I have root k is equal to 9. So how do I get rid of that root? I will then square both sides. Alright, so now I know that k is basically 9 squared, which is 81. Here I have a root to the 4th power, right? So how do I get rid of it? I will take it to the power of 4. And what I do on the left, I'll have to do on the right. So I'm left with k. And what is 4 to the power of 4? Let's just check. on the calculator over there. So 4 to the power 4 is 256. All right. Now here, 2 times k cubed. We're going to get rid of the 2 first. So now we have k cubed is equal to 128 divided by 2, which is going to be 64. Now, I have a k to the power 3. I'm going to get rid of it by having a cubed root. Okay, so we have k over there. And what's the cubed root of 64? That would be 4, but we can go ahead and check on the calculator. And there we go. Oh no. There we go. So we have 64. And that will be equal to 4. And ladies and gents, that is it. As my tablet dies, but we are done with the lesson. We used our time efficiently while taking a walk in the city. We're like, let's just record. And I hope this helps you to better understand what you're doing in class. All right, until next time.